Consider this ionic compound Mx composed of the metal and a gas, X2 here. We're trying to find the lattice energy when we form this based off of all this information. And the way to do that, first we're given the standard enthalpy of formation here of Mx, so it kind of takes care of this thing over here. We'll just make a little mark of that as 587 over there. But essentially we have all of these pieces of information that we have to break apart. So the sublimation step, that's going to be basically from going from solid to the gas form of this metal. And we're just going to cost 155, so that's fine. Now the ionization energy of the metal means that we're going to take that metal and we're going to take away the electron. So this is the gaseous form, by the way. But let's go ahead and take out that electron on this side. And of course, that's going to leave us with a positive charge on there. Now we got the electron affinity, and that's essentially the opposite of what happened here. So we'll go ahead and take our X, that's again the gaseous form, but we're going to add the electron on this side now. And, well, when you do that, this will turn into a minus ion here. So that's going to cost that much energy. And then here we're going to break apart this X2 bond that's in the gas form, and it's just going to become two X's. Okay, so now I can kind of already see, if I was going to add this all up, we'd get an imbalance here. We've got two X's on this side in gas form, and there's only one X over here. So I'm going to go multiply this by 2, which means I have to multiply the energy by 2 as well. And so that's going to give me 2X, 2 electrons here. But since I multiplied this electron by 2, I also have to multiply this electron by 2, otherwise it's not going to cancel out. You have to multiply that by 2. And now that I have two gaseous non-charged ones, one here and then one there, these gaseous things, and these things have to cancel. So I need to multiply this top one by 2 in order to get 2 of those. So now I've multiplied everything by 2. So we can try to get the total equation on this side here. Let's see what's on the left side. So we're going to have 2 of the solid M's plus 2 of the gaseous M's plus 2 XG's plus 2 electrons plus an X2 in the gas form. On the right side, we're going to get 2 of the gaseous forms, M, plus 2 MG's, those are positives, plus 2 of those electrons, and then there's 2 of the X and negatives, and then there is 2X in the regular gas form. Now we could try to see what cancels out. So let's see, we got 2 of these that will cancel with that, and we even have 2 of these that will cancel with that. We have 2 electrons, and I think that works out. So essentially, we're looking at something like this. We say that 2 of the solid metals plus this X2 gas becomes 2 mx, because it's a plus and a minus right there. So that's kind of cool. To figure out the lattice energy, we could try 2 things. We could take the E, the products, minus the energy of the reactants, or we could take the broken bonds minus the formed stuff. So we could do either one of those. And let's just go ahead and start with this side. We'll take a look at what the products are. The products have to be on the right side. So a whole bunch of stuff is over here. This has to do with the ionization energy. We're going to basically go ahead and add an electron on this side and call that our ionization energy. So we got 2 times the 423 is going to be a part of that right side. This MX business, we already figured out what the standard enthalpy of that is, but let's keep in mind there were going to be 2 of these, so let's multiply that by 2. So we got 587 times 2 there. Any other products? Well, I don't think so. I think those are the only things that are going to be on the product side. So then on the left side, and that's going to take care of this and this, which means on the left side we broke this bond, so we turned this thing into that. We're going to give that 151 over there. And then we also gave this electron thing over here, so let's put that in there. There was 2 of them, but you know it's going to be 2 times 303. And so that takes care of that one and that one. And then the sublimation thing is also going to be on this side. So we got 2 times 155. So we can kind of see that we've organized things based off what happened on the product side, what happened on the reactant side. Let's go and try to calculate that. So we're going to go 2 times 587 plus 2 times 423. So it gives about 2020 on this side. And on the left side, we would have 2 times 303 plus 2 times 155 plus 151 will give us 1,067. So let's take 2020 minus 1067. We're going to get 953 is going to be one of our answers. So 953